Hey there, this video is going to talk to you briefly about data representation. It's going to continue from the last video, but it's just going to quickly talk over how binary and hex works, and it's also going to show you how to do some binary addition. So without further ado, let's move on to the next slide. So we're going to be learning how to add binary today, but we're also going to learn about hexadecimal and develop a bit more of an understanding to help you with it. So if you think about how we add regular numbers, you may have learned this older number system at school where you see 8 plus the 9 is 17. So you've got your 7, which is your unit, and you carry the 1. And the next thing that you would do is you would add the 3, the 2, and the 1, which would end up giving you 67. So that is 28 plus the 39 gives you the 67. So that is how we do it with base 10, okay? So denary or denary. But what we're going to learn about today is you're going to learn how to do it with binary. And it's a very similar number system in that you do the carrying as it goes on. So we're going to work through that today, and you're also going to learn a little bit about hexadecimal. Now, when we add numbers together in base 10, okay, this is what they look like. So 1 is 1 in binary, okay? 2 in base 10 is 1, 0. 3 is 1, 1. 4 is 1, 0, 0. 5 is 1, 0, 1. But what you can see is that each time the number increases, we're moving over to another representation because we've got 1, 2, and 4, and 8. But you can see each time we are moving over to another place value. So we've got 1, 2, 4, 8 as our numbers increase and as we add together. It's the same as we use with our base 10 denary system. So just to help you get your head around that for a moment. Now, these are the general rules that I use to help my students, or if you are one of my students, this is what we tend to use. So if you've got 0 plus 0, obviously that is 0. If we've got 0 plus 1, it is a 1, nothing to carry. Or 1 plus 0 is a 1 and a 0. If it's 1 plus 1, I want you to think about what that looks like in binary. It looks like this. It's 2, which is 1, 0. So therefore, you would carry the 1, and you'll see how this works in a minute. Now, one that I've left off here is 1 plus 1 plus 1. Now, this rule would be a 1, and then you would carry a 1. Now, I'm going to show you how that works in a minute in a sum that I've got on my screen. But that's basically the general rules. As long as you can remember, a 1 and a 0 is a 1 with nothing to carry. A 1 and a 1 is a 0 with 1 to carry. And a 1 plus 1 plus 1 is 1 with 1 to carry. As long as you remember that, you are fine when it comes to adding binary numbers together. So what I've got here is an example of a sum. All right. So I've got to add 1, 0, 1, 1, 2, 1, 1. All right. So that's 11 plus 3. I always get my students to do this, work out what it is in denary, just so they can double check their answer. That way they know whether they've gone right or wrong. So if I've got 1 plus 1, remember the general rule was a 0, and then you would carry over the 1. So what's happened here is 1 plus 1 is 0, carry the 1. Now, what we've got is our rule from before, 1 plus 1 plus 1 is 1, carry a 1. So now I've got a 1 plus 0, which is a 1. Assume that this is a 0, and we've got 1 plus 0. In fact, if I put them in there, that might help you. A 1 plus a 0 is a 1. Now, going by place value to check that that is 14, we've got 1, 2, 4, and 8. Just to do this quickly, 8 plus 2 is 10, plus the 4 is 14. That is our correct answer. I hope that's useful. If you need to, just replay that back and talk about and look at how I talked about carrying over. That should help you with your binary addition. Now it's your turn. See if you can have a go of these. It might be good for you to pause this video and just double check your answers. Okay, so pause at this point, pause this video, give these questions a go. Now I've highlighted 3 of these with problems. Okay, I'm not going to tell you what they are just yet and what you'll be looking for, because we can do that on the next slide. Now, the problem that you had with the others, the reason why I highlighted those in orange, is that they had something called an overflow error. When you add 2 numbers together, if they are both 8 bits and you want to make an 8-bit number, unfortunately, the largest number you can store in 8 bits or in a byte is 255. If it doesn't fit in that, you have something called an overflow error. It means that the number is too large to fit in the bits that you have allocated it, which basically means it's going to cut that number off and you're going to end up with an inaccurate number. Now, you need to know what an overflow error is in your GCSE, and you need to be able to explain that in as much detail as I have just put here on this slide. So you would end up with an extra bit which doesn't fit into a byte, and this would be lost and it would give you an inaccurate number. You may have to add 2 numbers together in your GCSE paper, and you need to be able to explain what an overflow error is. So bear that in mind. Now, if you go on the website math-aids.com, so that's math, math-aids.com, there are activity sheets that you can download to actually do your own binary addition, and they generate the answers for you, so you can keep attempting and keep trying these over and over and over. So I recommend going to math-aids.com. There are number system worksheets on there, and they generate them at random so that you can try adding some binary numbers together. If not, come and see me in a lesson and I will give you some extra sheets. I will generate some for you if you do not have access to a printer. So now that you've understood how to add binary, we're going to generate hexadecimal. So our second part of this lesson is that you're going to learn about hexadecimal. Now our number system goes up to 10. Hexadecimal was developed because binary is difficult to remember, and also hexadecimal fits nicely into 4 bits. It fits into a nibble. Now, hexadecimal is a base 16 number system in that it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it goes A, B, C, D, E, F. Now, the equivalent of that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That would be the equivalent that you would end up with in hexadecimal. Now, it fits exactly into 4 bits, which I've said before is a nibble, okay? I've explained that the number system goes between 0 and 15. A would represent 10, B is 11, C is 12, D is 13, E is 14, and F is 15. And that's how the number system moves up. Now, this is a quick guide to show you how to convert it. So if I'm given 5F, what I can do is I can split the F into 4, and I can split the 5 into 4. Now, if I was to convert the F into denary, the F represents for me 15. So the F represents 15. 15 in binary is 1, 1, 1, 1. Now, 5 in binary is 1, 0, 1, 0. So you can see I split it into 4 bits each. So I've got 2 nibbles going here. Now, once you've done that, you convert it into binary. To do that, you just get rid of this in the middle. Join that together from the right to the left, and then you can convert that slowly and you end up with your final answer, which is 95. That is how you convert from hex to denary or decimal. All right. Now the same works if you need to convert it back. You would need to convert 95 to binary. Then you'd need to split the binary by going 1, 2, 3, 4. Split it down. 1, 2, 3, 4, and split it again, just in case you get more than 2 hexadecimal digits. All right, bear that in mind. Now, this is a breakdown of how I've done it. So what I start off with, if you have your binary number, which I've written out here, I've started from the right and counted 4 bits. 1, 2, 3, 4. Split that down the middle. 1, 2, 3, 4. So you can see that I've done that here. Now, I put the place value above it, 1, 2, 4, 8, 1, 2, 4, 8. And I've worked out what the denary or denary value is of each one. So I've got 11 and 12. All I've done then is gone over here and wrote out my hexadecimal grid, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. I know that A is 10, therefore B is 11, and C is 12. So my answer is BC. That is how you do a simple conversion from binary to hexadecimal. So now that you've tried it, see how you get on with these. You might want to pause the video so that you can attempt these. And I hope that that has been really useful for helping you work out binary, helping you convert from binary to hexadecimal and vice versa. Again, there are a number of worksheets around the internet that you can get hold of. If you want some extra from me, come and see me in the lesson and I will help you with that. And I will give you a copy of this and a number of other worksheets. Thank you for watching this video. I hope this helps you with hexadecimal and binary conversion. See you later.